Hello everyone. So I am back with another video, and in this video we are going to understand how internet travels your mobile device, your laptop device, or your television, anything, and how is it so fast throughout the globe. So if you want to send any message to your relative or do a video call to your relative who is living like seven seas across, so you can do it in milliseconds, and we will see how it exactly happens. So yeah, we have in um, thick wires which are installed under the sea, and these are basically undersea fiber which is connected. So there are two ways in which internet could reach your device. One is the satellite, and another one is this undersea fiber which exists. So these fibers are so much in length that it can cover our globe at least like 30 to 20 times. So it's pretty much lengthy. And let's see how it's built and what is being used to build it. So fiber optic cable is something which is used to build these wires, and each fiber optic cable is less thinner than your hair, human hair. And so this is one of the wavelengths which is traveling inside the optic fiber, and it's being collided on the edges. And the basic idea is to use this material because it has no electric resistance and no electromagnetic interference. So the benefit of this is that each of the wavelength could travel with a speed of light in this particular uh, small fiber which we have. And it's very interesting. So also the wavelength is being generated via laser. So light is being used to generate this, and light travels at its own speed, and it could carry 1 billion times bits per second, which is a lot. And 1 billion bits is around 1 GB, I believe so. And each of the laser is one wavelength. So concurrently, we could use 80 to 90 lasers in some average fiber optics, and even 100 to 200 in few of the cables. So imagine this: 100 to 200 lasers are being sent at once. So multiple wavelengths are being sent, which means multiple requests could be sent, and each wavelength is 1 billion times. So 200 into 1 billion bits, you can imagine the scale of this, right? And yeah, this was the basic idea. And the core is the light speed signal reflect the light inwards. Like I said, it collides, and protective layer outside, because this needs to be there because your wire and optic fiber is under the sea, so no water could destroy it. And there are times, many times, these gets destroyed due to some of the other reasons. Either sharks bite it and breaks it. So these are also scenarios which has been faced by the companies before. So it's very dangerous to have broken pipes inside the ocean. It could also lead to earthquakes. So it's a disaster to have it. So it's quite a task to manage this. And dozens of lights wavelength travel simultaneously, like the way I mentioned. So this was the basic explanation and all you needed to know. Also, you could do your own research to dive deeper into it. But yeah, there is also a ship which is used to set this pipe up. There are videos online you could see if you are more interested. But yeah, this was the basic overview of how are optic cables being set in under the ocean and what are being used, and how is it so fast. We have data center, which is another physical layer. So in the center there are various things which are integrated, and this is basically the infrastructure. So the main part is the physical infrastructure, and in this infrastructure we have power, cooling, units, and physical security. So power, this is uninterrupted power supply. So which is very important whenever the power is being cut, it is used to instantly get the power back. So it avoids any latency or any disruption. Generators are used to help these power supply. Cooling agents are used because whenever we have this high tech, so there is a lot of heat which is generated. So these cooling agents are being used in this infrastructure. And then we have physical security like biometric and what how many people are there in this infrastructure and etc things. So the main cost is in the power and the cooling which we have in this physical infrastructure. Next, we have three-layer hierarchical architecture, which is core switches, aggregation layer, and edges, which are also called as core layer, distribution layer, and access layer. These are bidirectional and it can send from the very bottom and can also send from the very top. So this is how the flow works. So core layer, imagine core layer is something which increases the speed of the packets which are being transmitted. So the main idea is to increase the speed of this transmission. This is the very top layer, interconnects subnetworks and data centers. So it is used to combine all the traffic which is being generated and being used, and it also is interconnected with each other. So this bridges the gap whatever we have it in the infrastructure, and also distributed layer reports to these core layers as well. So it's very high in speed and it uses various switching techniques for this high speed, which is another topic to be discussed, which we will not cover in this video. But if you want me to cover, just let me know in the comment section and we will do that as well. And the scalability is very high, and yeah, that is pretty much it. So the core idea is to increase the speed, and whatever data packets is being coming from the internet, it gets received at the core, or whatever distributed layer is being sending to the core layer, it sends to the internet at a very fast speed. Then comes the distribution layer. So this layer is very important layer which sits between the core and the access layer. So the task, what it does is it multiplexes the signals or networks which are being received. So multiplexing basically means combining efficiently the signals which are being received. So if there are thousands of signals, so it converts those thousand signals into one high frequency signal and pass it to the core layer. In this process, it also filters out unnecessary packets which are being transmitted and which are not needed. It also implements load balancing, which helps in the core layer for distributing the load evenly, and it's very smart to distribute it itself. So it aggregates multiple signals from the access layer, combines and converts it into a single layer at the core level. So yeah, that is pretty much it. And aggregate traffic, apply policies and route logically. So it also helps in the security of your system. It also is used at times when there is any failure. So whenever it wants to switch any route, it could do. So for example, one of the routes get crashed or gets leaked, so it can avoid sending the signals to those to that particular route. Therefore, this is good for the performance purpose. Next, we have access layer. So in access layer, we basically connect the local devices like mobile phones, etc., from the internet. So this is like the whole picture of this three-tier architecture of networking. And yeah, edge layer connects to end-to-end devices, provide device connectivity. Hmm. Next, we have rack rows. So these are real compute services servers. So whatever API or backend infrastructure or Kubernetes, everything which is being implemented in your application runs on this rack, and these are physical racks, and it is a place you could see this image for the same. And whenever you deploy your application or your backend, it gets deployed in these racks. Hmm. Next is storage rows. So these contains HDD, SSD, and NAS arrays. So this is HDD and SSD. These are basically disk which are used in your computer or mobile device and the systems. So this have block storage, then file storage and object storage. So block storage is basically you could see, so imagine block storage as disk in your software. So these disks acts as multiple blocks. So imagine you have a large land, and those land are divided into small parts. So block storage does this division. And file storage could be each of the buildings which are on your land. So file storage is something which you have in your system to store your files, which uses this NAS. And last is object storage, which you store basically on cloud or anywhere. On You might have heard about AWS S3 bucket, so it uses like the object storage. Next is GPU cluster. So whatever high performance computational work your system has to do is being done via GPU, because it can do tasks very much better in efficiency compared to CPU. And whatever task, for example, loading the graphics or running something in low FPS, so this is being done via GPU. And any AI related work, because it's requires like high workload. So yeah, this is being done on the GPU cluster. Next and the final layer which we have in this data center is the internet uplinks. So imagine this as storing everything private, and this is the last step where all the private networks will be exposed to the world and to the globe. So this has basically three ways. One is it uses the fiber, and another is it uses the internet service providers, and last is the internet exchange points. So these providers are nothing but the SIM card or internet service which you use, let's say Geo or Airtel. And these exchange points is something which we will see next in detail. But the basic structure is your device is being directly connected to the service which you require. So yeah, an internet service provider, let's see this in detail. So how exactly your data is being transmitted from one end to another. So internet uplinks connects data center to global internet. As we saw, edge router is runs BGP, which is border gateway protocol, and routes external traffic. So everything which we saw was private and will be made public in this layer, which is done by the edge router, which we also saw in this access layer. So access layer and edge router are same, so don't get confused there. And the last is the border gateway protocol. So this is very important. So it decides the best path for reaching from your server, from your source to the destination. So each of the internet providers like Geo or Airtel may have different policies applied for this border gateway protocol. And why is that so? Because whenever the packets are being transferred from one device to another, it could use any service provider. Even if you have Geo SIM card and Geo internet in your device, it will use Airtel providers infrastructure as well if the destination user is close to the Airtel provider. And it's very interesting. So whenever, let's say, there is user A, user B, user A has Geo, user B also has Geo. So initially the transmission will be done from the internet provider which they support, which is Geo. And then if this final person lives near the Airtel infrastructure, this Geo packet will be converted or passed on to the Airtel provider, and then that provider will pass on the packet or the request or whatever the data was sent to the user. So one question may arise that even if, so if internet uses same um, internet providers via transmitting, why don't we have one common service or one common provider, right? So for this particular reason, there are different policies which are set for the border gateway protocol, which could be, let's say, Geo supports the fastest path, but Airtel wants to support the cheapest path. So this is also being handled by border gateway protocol. Next is internet exchange points, and imagine internet exchange point as something where all the server is being kept locally and your internet provider has access to connecting to it directly. So if you want to search Google on browser without IXP, what network path it may take could be, if you are located in Mumbai, so from Mumbai to London to Google, and that would take around 200 to 400 milliseconds. And if we have IXP local server of Google stored, so your ISP, which is Internet Service Provider, could be Geo. So Geo might be connected with this Google local server in this Mumbai infrastructure. So if you are closest to this infrastructure rather than closest to London, so it will connect your request to this infrastructure. And this connecting is being done by um, BGP, which we saw previously. So yes, this is very important as it reduces the latency to, like, if it's taking 200 to 400, it will reduce to 5 to 4 milliseconds. That's a huge improvement, right? So for Airtel ISP, so one side will be Airtel, one side will be Jio, and there could be other internet providers as well. This will be switching fabric of IXP. So switching fabric is nothing but the material and the way approach which we use for connecting these two providers. And this is the content provider. It could be anything, Google, AWS, and any other providers which the user wants to connect. So user will use one of these ISP, and it could easily get the providers in lesser amount of time. So it goes with low latency, better resilience, and lesser than 5 millisecond if it just connects like this. And if it goes till London, it could also take 200 milliseconds. So this is a huge improvement. The last and final one is the last mile problem. So last mile problem is something, so you build all the infrastructure connecting from your local native place till London, till anywhere around the world. But you also want internet at home, right? So wherever you are using your mobile device or your television, so you need internet to be accessed at that particular location and not at just the infrastructure where it's built. So to solve this problem, we have this last mile thing, like the final connection to your home. So there are multiple ways in which this could be solved, and each of the ways have its own pros and cons. So let's see what is it. When on the higher hierarchy is the internet providers which we have, like the SIM card or the Wi-Fi companies which we use, Hathway, Geo, Airtel. So these are like the providers which act as backbone for the connection. Then we have street cabinet. You might have seen something like this on your street as well. So these are street cabinet, and um, don't misunderstand this with um, cable one. So it it could be the cable one as well, like if it's being integrated in the same, but I'm not pretty sure about it. But yeah, this is something which we all have already seen, but and it contains all this infrastructure. So connection one, I believe the one which we have near our society could be something related to this. So you know what? Let's just search street cabinet. This street cabinet, the one which we have in our society. Let's see. Here's the metal box you see near, often on the pavement and near the entrance is almost certainly street cabinet. Okay, so this holds all the um, communication which we have, broadband and telecom distribution, weather protection, 5G fiber network nodes. That's interesting. That's pretty interesting. Okay. Hmm. Then these street cabinets are provides these all services and these all ways which you want to access the internet. So FTTH is fiber to the home. So this is basically having the same fiber optics which we used inside the sea. So having the same at near your home. So it's not pretty much possible. So because it requires to um, dig the ground and insert those wires inside the ground and connect to your home. So it's not very much cost effective if you just want to connect it at one single home. And it also requires various permission from governments to dig the ground and insert these things. So these are very high costing, and it basically gives the best performance. Like it goes like 100 or 1 Gbps per second, which is a lot. And we don't need this fast internet at our home unless you are doing any extremely um, high computing stuff. Then we have DSL and copper. These are something which is declining in India. Like people are stopping to use this because there are many reasons. It uses telephone copper wire. Copper wires are not very efficient when it comes to passing on the data. It has more maintenance cost as well. So it could physically be rusted or any reason, because copper is quite sensitive to manage. So it's also something which was used in like traditional days in other countries like Europe, but India was something which went on with the fiber approach rather than copper, because one, it was very traditional until the trend got into picture. Copper was already outdated, and it's very sensitive to temperature and physical maintenance. Therefore copper is something which was neglected. Then we have fixed wireless approach. And, like this is one of the most used approach. Like it's basically connecting your premises equipment to the tower which we have. Like imagine it like that. You might have seen antennas at the terrace of your society. So these antennas are directly connected, like it gets connected with the towers which we have, and using that it could um, get access to the internet, and those towers are connected with the fibers. So we can get the access of internet via this approach. These uses like the radio waves from the premises equipment till the tower, and tower is connected with the fiber which we have, and that fiber is directly connected to internet. So it makes the connection and access to internet very quick, with very efficient way of connecting. Like it's wireless, so antenna does not need any wire, it just directly connects with the radio waves. So, and last is satellite Leo, which is basically connecting your internet to the satellite and getting it back. So no ground cables needed, satellite orbit, which takes a lot of time as well, and higher hardware cost is also something which is one of the conditions in this. So this was pretty much it, and this was the full flow of how internet connection works um, around the world and how it reaches to your home. So this was the complete flow. So your device, Wi-Fi, which we have, then last mile, which we saw how fixed wireless access is something which we use. Fiber is something which is constrained with the government permissions, and but it is the most fastest. DSL is something which is where copper is used. Then we have ISP, which is internet service provider, and IXP, which was internet exchange point. Then Fire backbone. These could be like Bharat Net is something which is one of the fire bones which is used. So Bharat Net is something which is doing the work of connecting these copper, not copper, but fibers to the Panchayat. So in the previous years, internet was not much accessible to the rural parts of India, but BharatNet has got the contract and they are doing the work for connecting the Gram Panchayat, and then any local internet provider could get the access from the Gram Panchayat about for this speed of network and can easily pass on the internet in the rural area. So let's see BharatNet, if I'm not wrong. Yes, sir, it's the same. Yeah, perfect. BharatNet, yes, that's right. Data center and response. All right, I believe this was it. And I hope you liked this video. If you did, um, leave a like on this video and comment if you have any doubts or if you didn't understand any part properly. But yeah, thanks for watching and see you in the next one.